In this video, we're talking about how to find the slope and the midpoint of a line segment when we're given the endpoints of the line segment. And in order to find the slope and midpoint, we're just going to need to use a couple of simple formulas. So to find the midpoint of the line segment that connects these two endpoints, so one end of the line segment is at the point -3, -1. The other end of the line segment is at the point 3, 3. So if we graphed this, we would plot a point at 3, -1 and a point at 3, 3. And we would connect them. So if we're going to find the midpoint, all we have to do is take the two x values in our coordinate points, add them together, and divide by 2. We'll do the same thing with the y coordinates. So if we say that our x coordinate for the midpoint is -3 plus 3, when we take the x value here, -3, and add it to the other x value, 3, so -3 plus 3, and then we divide by 2. And the y coordinate of the midpoint is going to be whatever we get when we add the two y values and divide by 2. So we're going to say -1 plus 3, and we're going to divide that sum by 2. So -1 plus 3, and we're going to divide this by 2. So when we simplify here, -3 plus 3 is 0. 0 divided by 2 is still 0. -1 plus 3 is 2. 2 divided by 2 is 1. So the midpoint of the line segment that connects these two endpoints is the point 0, 1. And if again you plot these points, -3, -1, and 3, 3, and you connect them with a line to make a line segment, and then you plot the point 0, 1, it should appear as though 0, 1 is exactly in the middle of this line segment. Now, in the same way that we use this formula to find the midpoint, we're going to use a similar formula to find the slope. To find slope, we're going to take the change in y divided by the change in x. So the important thing here is that we always start with the same coordinate. So what we're going to do is we're going to say change in y over change in x, and we usually define slope as m. So we're going to say the slope m is going to be equal to the change in y, or delta y, that's this Greek symbol here, delta y, or the change in y, divided by the change in x. So when we do this, we're going to look at our two y coordinates here for the numerator. Our y coordinates are -1 and +3. It doesn't matter in which order we do our subtraction, as long as we keep it consistent when we do the x coordinates. So for example, if we say -1 minus 3, in other words, we're subtracting the y value in the second coordinate from the y value in the first coordinate. So we start with this and we say -1 minus +3. Then for change in x, because we started here with -1, we have to start with -3 in the corresponding coordinate. So we have to say -3 minus 3, -3 minus 3. If we had done +3 minus a -3 and gone in the opposite order, we would have run into trouble. So as long as you always start with the values in one coordinate and then subtract the values in the other coordinate, you're going to be good. So -1 minus 3 is going to give us a -4. -3 minus 3 is going to give us a -6, which when we simplify, the negatives will cancel and we'll end up with 2 over 3 when we reduce the fraction to its lowest terms. Now, just to prove to ourselves that we could have gone the other way as long as we kept it consistent, remember before we took the values in this first coordinate point and we subtracted the values in the second coordinate point. If we start with the second coordinate point instead and then subtract the values in the first coordinate point, we should still get the same slope. So again here, change in y, we're going to do 3 minus a -1. So 3 minus a -1 divided by the change in x, starting with the second point and subtracting the value in the first point, 3 minus a -3, so 3 minus a -3. When we simplify here, we're going to get 3 minus a negative is 3 plus 1, so 4. And here, 3 minus a -3, the negatives cancel, we get a positive sign. 3 plus 3 is 6. 4, 6 reduces to 2/3, which is the same slope we got when we went the other way. So either way, you're going to find the same value for the slope as long as you're consistent. Let's do this quickly with another example just to reinforce what we've learned. If we want to find the midpoint of this line segment, we have both endpoints of the line segment. What we want to do is, for the midpoint, add the x values together and then divide by 2. So we're going to get -5 plus 1, and we're going to divide that sum by 2. And for the y value, -2 plus -3 divided by 2. And when we simplify here, -5 plus 1 is a -4. -4 divided by 2 is going to be -2. Here for the y value, negative 2 plus a negative 3 is going to be negative 5. Negative 5 divided by 2 will still be negative 5 halves. We can't reduce that fraction any further. So the midpoint then is negative 2, negative 5 halves. And remember, negative 5 halves is the same as negative 2.5. So you could plot this point to verify that it is in fact the midpoint of the line segment connecting these two endpoints. And again, if we want to find the slope of the line segment that connects these endpoints, we'll say that the slope m is going to be equal to delta y over delta x, or the change in y divided by the change in x. And we'll take the second coordinate point here and subtract the first coordinate point. So we're going to say negative 3 minus a negative 2. So negative 3 minus a negative 2. And then for the denominator, the change in x, we have to start with the second point again, since we started with the second point to find the change in y. So we'll say 1 minus a negative 5, so 1 minus a negative 5, and now we simplify. So this minus a negative, those two negatives will cancel and become a positive sign. So negative 3 plus 2 is a negative 1. Here we're going to get these two negative signs to cancel. We get 1 plus 5, which is 6, and therefore we can say that the slope is negative 1/6.